Volcanoes are impressive natural structures in our planet, but did you know that some of them are so huge and powerful that they can actually change all of our planet's climate and potentially kill all life on Earth? Stay tuned, because supervolcanoes are definitely something everyone should be aware of. The Roman god Vulcan gave rise to the word volcano. Vulcan is the Roman god of fire, who is most associated with its destructive manifestations, such as volcanoes and wildfires. We will learn about supervolcanoes in this video, including how they are formed and how they can impact the climate of our whole planet. Supervolcanoes. A supervolcano is a volcano that has had an eruption with a volcanic explosivity index, VEI, of 8, the highest value ever recorded on the index. This suggests that such an eruption would result in the production of sediments larger than 1,000 cubic kilometers, 240 cubic miles. Volcanic eruptions are categorized using the Volcanic Explosivity Index, or VEI for short. A 1-point rise in the VEI score translates to a tenfold increase in the volume of material that has been erupted because the scale is logarithmic. VEI 7 or VEI 8 eruptions usually result in circular calderas rather than cones because of the downward outflow of magma. The term magma refers to the molten rock that is underground, and the term lava is the molten rock that breaks through the Earth's surface. When magma from the mantle rises into the crust but is unable to penetrate it, supervolcanoes form. A vast, expanding magma pool experiences increasing pressure until the crust can no longer withstand it and ruptures. Temperatures and pressures rise as the falling landmass descends deeper down, forcing the water out of the rocks. By lowering the melting point of the rocks above, the water creates magma, which can power more eruptions. Hotspots like the Yellowstone caldera or subduction zones like Toba and Sumatra, Indonesia are examples of places where this supervolcanoes might happen. How dangerous supervolcanoes are? As reports of the impending threat from supervolcanoes become even more harmful, they are akin to the mobsters of the geologic world. Massive eruptions can be dangerous, yet there are many myths about them. 90% of people could die within 1,000 miles of the explosion, which would present the most threat. People would perish in great numbers all around the nation because breathed ash causes a cement-like substance to develop in the lungs. 1 centimeter of ash might even paralyze the U.S. East Coast. We may use Mount Tambora's eruption in Indonesia in 1815 to get a sense of what would happen in such an event. Even though this explosion only had a VEI of 7, it nonetheless illustrates the numerous risks associated with such megablasts. The explosion launched a 28-mile-high superheated plume of hot ash and gas, which when it crashed produced pyroclastic flows, paralyzing the icehouse. Around 10,000 individuals were killed by such direct dangers. But that wasn't the only issue. The year without summer was caused by the gases and ash that were released into the atmosphere, which darkened the skies, blocked out the sun, and changed the climate. Following widespread crop failures, famine, and disease, approximately 82,000 additional people died. An estimated 20 million tons of sulfur dioxide and ash particles were launched more than 12 miles, 20 kilometers, into the atmosphere when Mount Pinatubo erupted in the Philippines on June 15, 1991. The eruption left behind extensive damage and human casualties. For 3 weeks, the world was encircled by gases and solids that were released into the stratosphere. Volcanic eruptions of this size can alter air circulation patterns, reduce the quantity of solar radiation reaching the Earth's surface, and lower tropospheric temperatures. How do they change the climate? Although intense volcanic activity may only last a few days, the vast release of gases and ash can have a long-lasting impact on climatic patterns. The sun would be obscured by the ash, causing an abrupt dip in global temperature of up to 10 degrees. It might even cause a brief ice age. Sulfuric gases change into sulfate aerosols, which are submicron-sized particles that contain roughly 75% sulfuric acid. These aerosol particles can stay in the stratosphere for up to 3 to 4 years after eruptions. Because volcanic aerosol clouds absorb solar radiation and deflect a sizable portion of it, major eruptions change the Earth's radiative balance. This effect, known as radiative forcing, can last for up to 3 years after a volcanic eruption. The researchers discovered that the climate model predicted a general cooling of the global troposphere, but produced a pronounced winter warming pattern of surface air temperature over northern hemisphere continents. By contrasting the simulations of the Pinatubo eruption with and without aerosols. Due to aerosol absorption of solar, near-infrared, and long-wave radiation, The temperature of the tropical lower stratosphere rose by 4 Kelvin, 4 degrees Celsius. The models show that volcanic aerosols' direct radiative effect results in general stratospheric heating and tropospheric cooling, with a pattern of tropospheric warming in the winter. According to Stenchikov, anthropogenic emissions can exacerbate the effects of volcanic eruptions on the world climate system. For instance, the presence of chlorofluorocarbons, CFCs, in the atmosphere sets off a series of chemical processes on aerosol surfaces that deplete the stratosphere of ozone in the mid-latitudes. Again, these volcanoes cause large earthquakes to occur. Let's look at some of the world's most lethal supervolcanoes. Yellowstone supervolcano. The calderas are located over the Yellowstone hotspot, under the Yellowstone Plain, where hot, glowing magma is rising from the core. The hotspot, which is responsible for the eastern half of Idaho's Snake River Plain, appears to move across the landscape in an east-northeast direction, but in reality, it is much deeper than the nearby terrain and stays stationary as the North American plate moves over it in a west-southwest direction. This hotspot has produced a series of explosive eruptions and less violent flows of basaltic lava over the past 16.5 million years or so. Together, these eruptions helped transform an area that was formerly mountainous into the eastern Snake River Plain. Many of these eruptions, at least 12, were so large that these eruptions qualified as supereruptions. The 2013 earthquake data analysis revealed that the magma chamber is 80 kilometers 50 miles long and 20 kilometers 12 miles wide. Additionally, it possesses a subsurface volume of 4,000 cubic kilometers 960 cubic miles, of which 6 to 8% is made up of molten rock. This is nearly 2.5 times larger than scientists had previously predicted, but they think there is not enough molten rock in the chamber to support another supereruption. According to research published in October 2017, there were 2 significant influxes of magma into the magma chamber before Yellowstone's most recent supereruption. Crystals from Yellowstone's lava were examined, and the results revealed that the magma chamber experienced a significant rise in temperature and composition before the most recent supereruption. The analysis showed that, contrary to what volcanologists had previously believed, Yellowstone's magma tank can achieve eruptive capability and cause a supereruption in just a few decades. Toba eruption. The youngest Toba eruption was a supervolcano eruption that took place in the location of the present-day Lake Toba in Sumatra, Indonesia, about 74,000 years ago. This eruption, which occurred during the Quaternary period and was the last and greatest of 4 eruptions of the Toba caldera complex, is also identifiable by its characteristic horizon of ashfall, the youngest Toba tuff. It made a significant contribution to the 100 kilometers by 35 kilometers caldera complex and was predicted to have a volcanic explosivity index, VEI, of 8, which is the highest rating on the scale. Dense rock equivalent, DRE, estimations of the eruption's eruptive volume range from 2,000 cubic kilometers to 3,000 cubic kilometers. Toba eruption was one of the greatest explosive eruptions on the planet. According to the Toba catastrophe theory, this event resulted in a global volcanic winter lasting 6 to 10 years, and perhaps a cold phase lasting 1,000 years, which triggered a population bottleneck in mankind. Scientists concur that a supervolcanic eruption of the magnitude that occurred in the Toba caldera complex must have resulted in massive ashfall layers and the release of toxic gases into the atmosphere, having an impact on weather and climate around the world. The eruption mass was at least 12 times larger than that of Mount Tambora's 1815 eruption in Indonesia, which was the greatest volcanic eruption in recent memory. Over all of South Asia, the ash layer left by Toba's eruption was around 15 centimeters, 6 inches deep. Additionally, the Indian Ocean, the Arabian Sea, and the South China Sea were covered in a layer of volcanic ash. Taupo supervolcano. The Taupo volcano, a huge rhyolitic supervolcano, has its caldera in Lake Taupo, which is in the middle of New Zealand's North Island. In geologically recent ages, this enormous volcano has generated 2 of the most catastrophic eruptions in history. About 300,000 years ago, Taupo started to erupt. The dacitic Mount Tohara eruption, which occurred 65,000 years ago, and the Oronui eruption, which formed the present caldera around 26,500 years ago, are the 2 main eruptions that continue to have an impact on the area's topography. With a volcanic explosivity index of 8, the Oronui eruption of the Taupo volcano was the greatest known eruption in the past 70,000 years. Around 26,500 years ago, it took place and produced 500 430 cubic kilometers of magma, in addition to 430 cubic kilometers of pyroclastic fall deposits, 320 cubic kilometers of pyroclastic density current (PDC) deposits, and 420 cubic kilometers of primary intracalderar material. So friends, what did you think of these huge volcanoes? Would you be scared if one exploded? What would you do? Let us know in the comments below. Thanks for watching and see you on the next video.